Yo, what's up, everyone? Good morning. Welcome back. May 13th, week 7. We won't go past week 10, so we got wow, that's crazy to think. Maybe only 7 more problem sets for the year. So, yeah, I'm happy you're here. And maybe some of you weren't thrilled when you printed the worksheet and saw some word problems. But word problems and graphing, in my opinion, tie and kind of give context to everything we do with the actual math, right? So we focus so heavily on the actual math in this class, right? We rarely talk about word problems. We do a decent amount of graphing, but I think it's really important to, with most topics, kind of approach what kind of word problems we would do. Why is this useful in any way? So this probably looks intimidating, but the good news is there's no new math today. Okay, so the math is what we've already done with trig, specifically the last lesson, which is kind of a lot. Okay, when we did SOHCAHTOA. So what we've essentially learned is that if we have a triangle and this first one's a ladder problem, as long as we know one side of the triangle and one angle, we can solve everything else about that triangle, meaning every other angle and every other side, just by using sine, cosine, or tangent. Okay, so the key to this is going to be sometimes you have to sketch them on your own, sometimes you won't. But to know what angles and what sides you're given, put them in your sketch, and then figure out what you have to solve for. Okay, so I think this shouldn't be too bad. Hopefully, you guys. The key is really just to kind of get into what the triangle is going to look like, right? Because all we're talking about is triangles, uh, and just figure out what the triangle would look like and what you already know. So for the first one, it just says a ladder is leaning against the side of a house and forms a 65-degree angle with the ground. The foot of the ladder is 8 feet from the house. So first, it gives us 65-degree angle with the ground. It says the side of the house forms a 65-degree angle. Oh, sorry, man. The ladder is forming a 65-degree angle with the ground. So this is that angle. And sometimes we call this the angle of elevation if we're going up somewhere. But that's this angle. Then it says that the foot of the ladder is 8 feet from the house. Okay, so think that this is the foot of the ladder and this is the house. So we are this far from the house. So in this example, think that this might be really easy to measure. If you're just working on your own, you could measure how far away you are from the house. You could even take out a protractor and figure out this angle. And that could help you figure out the length of the wall and then also the length of your ladder. Okay, so these were the two pieces of information we're given. And it says to find the length of the ladder, which is here. So in the context of a word problem, this might look like it's not a lot of information. But remember that for a trig function, you need two sides, and that's going to equal one of the functions and the angle. So if this is my angle, the key here is identify your two sides in context with this angle. So the ladder is the hypotenuse, right? Because it's the long side. The 8 that we know is the adjacent, because the hypotenuse is always the long side. And then if this is the angle, the opposite's the wall because it's on the opposite. So this has to be my adjacent. So I know the adjacent. I'm trying to solve for the hypotenuse. So I'm going to use cosine, right? From now on, SOHCAHTOA won't be in the title, but I kind of like to write it down because I find it really useful. Ka, adjacent, and hypothesis. So we're going to take this angle, cosine of 65, and that tells me the relationship between the adjacent and the hypotenuse. Man, the glare is bad today. It's a little cloudy. But yeah, we already know these, so let me just put in, it's going to be 8 over x. So it's the exact same thing we did before. And that's why I don't think you should be too worried. Okay. So we're plugging in the angle, which was cosine. Let me do this. Yeah, okay. We're plugging in the angle, so we'll have 65 cosine. So 0.44422. That's the ratio between these two angles. Sorry, these two sides. So that's what we have. And now if we want to get x by itself, we have to multiply to the other side first. But this is kind of how you do it every time. So hopefully you start getting really used to that like pattern. So all we're going to need to do is 8 divided by 0.422. Crap. And we'll get the length of the ladder as 18.96. And we could assume that's feet. Hopefully that makes sense. The rest of these are going to be very similar. We're just going to keep going over word problems. But the drawing is going to be really important. So when you do them on your own, a lot of them are going to be similar questions to what I did, just so that you don't get too intimidated. But there'll be some new concepts as well. For problem 2, we're going to have another ladder problem, but we're going to be given different information. Okay, so it says a 15-foot ladder is leaning against the side of a house. If the ladder is 5 feet away from the house, we want to sketch it. And here, we're given the length of the ladder, and we're given how far away it is from the house. You only need 2 pieces of information to solve anything. So I'm going to sketch here, and we'll sketch it the other way. And when you sketch, first, it doesn't even need to be to scale. It's okay if it doesn't look 100% accurate. And also, you don't need to do the fluffy stuff, right? As long as you can visualize whatever we're talking about. So my ladder is 5 feet away from the house, and it's 15 feet. So these are my 2 pieces of information. And first it wants us to find the angle of elevation. So that's going to be this angle. And to find this angle, this is actually going to be super similar to the last one, because we have the hypotenuse and we have the adjacent again. So if I want to find this angle, we're going to use cosine -1. So remember that if we're going to solve for an angle, we put the other side of the equation into the calculator, and that's going to solve theta for me. So we have both sides, so we know the ratio is going to be 0.33333. So we're going to plug that into theta. Hopefully everyone's still with me. And you know, this assignment, some of you might find really easy. Like, you don't need to watch the video. I'm not saying that you should stop watching, but if you feel like you really understand word problems, this whole thing is probably a good challenge for you. Okay, so that's my angle, 70 degrees. And then this question, I asked you 2 things. And what's really important to remember is that once you have 2 pieces of information for a right triangle, you can solve every single part of it. And if we need to find the third length, we should use a squared plus b squared equals c squared, okay? So we can solve every side of this once you have 2 sides. And we didn't do an example before where we weren't solving for the hypotenuse, but this is our formula to solve for, like, we can call this x. And here what's difficult is c squared is always the hypotenuse, the long side. So we have 15 squared. We can call this side a. And the complication here is going to be that we have to isolate this. So we're going to get 25 plus b squared equals, I'm pretty sure it's 225. Last time I made a funny mistake. So if you get to this part of the equation, let's just talk about how you would do it. Move 25 to the other side. So b squared equals 200. And now we just take the square root, right? The opposite of a squared. Good. So in this case, the length of the building would be 14.14. So you're going to use your sine, cosine, and tangent to find angles. And then also to find a side if you only have one. Okay, so one side of your triangle, you need an angle to find another side. But then once you have two sides, the third side is really easy. All right, let's tackle a few more. I hope this is useful to you. And I decided to do 5 questions, which now seems like a lot. And actually, I only have 15 minutes before homeroom. I usually don't do it at this time, but let's get it done. Stop rambling. Okay. It says a sonar operator on a cruiser detects a submarine at a distance of 500 meters at an angle of depression of 39 degrees. How deep is the submarine? So I stole this question, obviously. And if the question concept is really weird, I'm going to kind of give you the drawing. But I wanted to talk about this one specifically because it's talking about the angle of depression. And basically, an angle of elevation from the last one is, if we're at this point, the angle of elevation tells us like how much higher the next point is, right? Elevation is an angle going up. An angle of depression is going down. Okay, so if we're a boat, we're looking down on the submarine. Okay, so it's the angle at which you're looking down. In this case, this is not going to be challenging because we know trig. We have an angle and we have a side. But if you see angle of depression, that is indicating you're going down. And it's asking how deep the submarine is. So always be aware of what you're trying to solve for. We don't really care how far away it is, horizontally. We care about how deep the submarine is. And hopefully see how cool trig can be and how useful this application is, right? Like if you have a sonar, you can see that something's 500 feet away at a 37-degree angle. So you'll know, or you can solve how deep it is. The key is naming your sides, right? So this is my angle. So this is the opposite side. This is the long side, so it's the hypotenuse. So we're going to use sine here, right? So, and the angle is 37. So sine 37 equals this ratio of x over 500. So we'll do normal sine. Sine, crap, you always press the number first. So 37 sine is 0.602. And then this is the easier one to solve because you just multiply 500 this way and x is isolated. So we're just going to take that number we just had and multiply to 500. And that tells us that the, I'm good. That tells us that the submarine is 300 meters deep. All right, I went through the math kind of quick, but hopefully the setup makes sense and all that. I'm going to skip 4 because we've just done, actually wait, no, let's do it. We're not even doing too poorly on time. 4 is useful because we're going to sketch something that's completely new. It says in a parking garage, each level is 20 feet apart. Each ramp to a level is 130 feet long. And we want to sketch the situation. So here we're talking about a parking garage, and think that we're first going to sketch it. So think that parking garages have ramps, and it's saying that the ramp is 130 feet long. And each level, so think to go from level 1 to level 2, right? You start on level 1 and you get to level 2. That distance is 20 feet. I hope that makes sense. So you take a 130-foot ramp to get to the next level, but you're only going up 20 feet technically, because from the first level to the second level is 20 feet. So I think that I'm going to try to give you questions that aren't this hard to visualize, but hopefully you're able to visualize and take them slowly, right? As long as you can kind of think, okay, a parking garage ramp goes up and each level is 20 feet. I think that is doable. Then all it asks is what's the angle of elevation. So angle of elevation happens a lot when you're talking about like mountains or driving up mountains, like the grade of the mountain. And it's really like how steep it is, right? We want to know how steep this ramp is. And we have the perfect information to solve for that, because it takes us 130 feet of traveling to go up 20 feet. This is my opposite side. And then this is my hypotenuse. So we're going to use sine. And we're going to use sine -1 because we have two sides and we're trying to find an angle. Okay, so sine -1, you put in the ratio and it gives you the angle. So that's that. The ratio between opposite and hypotenuse is 0.154. And we'll do -1, and it's going to be 8.85. So maybe my drawing isn't perfectly to scale, but that part doesn't matter too much. This is a really thin angle, right? Only 8.85 degrees. Okay, excellent. So I actually decided we're not going to do the challenge. I think that that's not too useful. But you're going to have problems that are very similar to this. And then we'll move on next week to some more different stuff. But hopefully found this to be kind of a useful in context for trig. Alrighty, proud of you and appreciate you.